In this video, we are going to look at an example for quantitative data in sampling distributions for AP Statistics. Woot woot! We're awesome. Okay, please pause this video and read this description of this example because I don't want to read it to you. So basically what we have here, we have non-traditional students that attend college, and those are defined as those who are 25 years old or older. And we find that the GPA, or we're told that the GPA of those non-traditional students tends to have a mean of 3.5 and a standard deviation of 0.5 respectively. So we are going to take a random sample of 100 non-traditional students from the population. So in part A, we are told to find the mean and standard deviation of the sampling distribution. When you find a problem that asks you for the mean and standard deviation of the sampling distribution, this word right here, the sampling distribution, should indicate to you that you need to talk about the sample. Is it large enough? Is it small enough? Are the individuals independent? And is it random? So of course, that means everyone's favorite thing are conditions. Woot, woot. Okay, so we are told that it is a random sample of 100 students. So these 100 students definitely represent an SRS of all non-traditional students. Miss Griggs, do I have to write it that way? No, you don't. You could have said 100 non-traditional students were randomly sampled. Okay, there's a million different ways you can write this. I'm just trying to use my math words here. Simple random sample is what we want. Simple random sample is what we have. 100 students represents an SRS of all non-traditional students. There's no reason to assume these are not independent of one another, so I'm going to say that these 100 students are independent. And it also seems fairly reasonable that 100 students is definitely less than 10% of all non-traditional students. Okay, now we are not told in this particular problem that the parameters we are given up here come from a normal distribution. So I have to now analyze my sample size. So I look at my sample size and I see that it is 100. Well, by my central limit theorem, I need at least 30 individuals for it to be considered large enough to approximate normal. And clearly 100 is larger than 30. So what I'm going to write is that my sample is large enough by or according to the central limit theorem to approximate normal. Because remember, my central limit theorem tells me that if my sample's large enough, the shape will take on a normal shape and it will have reduced variability. So now I am going to find my parameters. My mean, of course, is going to be equal to the population mean that I was given, or the population estimated mean. My standard deviation is going to be 0.5 divided by the square root of 100 because there are 100 individuals. And so my sampling distribution for all sizes of 100 non-traditional students would have a mean of 3.5 GPA with a standard deviation of 0.05. That is your answer to part A. So let's look at part B. What is the approximate probability that the non-traditional student sample has a mean GPA between 3.4 and 3.65? So I'm going to draw my curve here. 3.5 goes in the middle. 3.4 goes below it. 3.65 goes above it. I want the probability of this shaded region right here. So the probability that the sample mean is between these values. That is what I'm looking up. So of course I'm going to go to my old pal Staplet, and I am going to type in a mean of 3.5 and a standard deviation of 0.05. And I want the area between two values, one of them being 3.4 and the other one being 3.65. And we get 97.59%. Magic. Now keep in mind you could have used the chart. If you did that, you would have had to find two z-scores. And then you would have had to find the area to the left of each of these, and then you would have had to subtract them. Okay? All right, you know you don't have to find the z-score for this problem unless you use the chart, but there you go. All right, part C. What is the approximate probability that the sample of 100 non-traditional students has a mean GPA that exceeds 3.62? So same exact kind of problem. We are looking for the probability that these 100 non-traditional students would have an average GPA above 3.62. So the probability that X bar is greater than 3.62. And then again, I'm just going to go to Staplet. And this time I want the area to the right of 3.62. .82%. Or 0.0082. So not very great. Anyway, so if, and again, remember if you use your chart for this one, once you find your z-score, you will look it up on the chart, and the area that your chart will give you will actually be this area, so you will have to subtract that area from 1 to get the shading to the right.